Our goal in this section is to be able to sketch the graphs of all 6 of our trigonometric functions. And what I've got here kind of as our starting point is the sine function kind of in all of its glory, right? We have the actual sine function. It is in here. It's kind of buried a little bit, lost in all of this noise. We've got a lot of other stuff going on. We've got, if you think back to the transformations that you learned in your college algebra or maybe pre-calc class, we've got a stretch here. We've got some vertical and horizontal shifts. And then we've got this omega here, which is going to do some interesting things. So what we're going to do is we're going to start with a sine function. All right, we're going to kind of use this as our base. All right, so first, let's look at the absolute simplest version. Take out all of that, all those extras, and just look at the sine of x. So what does this thing look like? All right, well, I've got a few basic facts here that are going to kind of guide us through doing this. First, the domain is all real numbers, right? So it's going to go the entire length, if you will, of the graph. The range goes from -1 to 1. We've seen this before, right? -1 is the minimum value of the sine function, and 1 is the maximum value. Now to make this look okay on my graph, I'm gonna adjust the scale a little bit. I really don't want to limit my graphs to being between here and here, right? So when I do this, I'm going to kind of let 1 be up here, maybe, and I'm just going to label everything appropriately so that you can tell what scale I'm using on each axis. Now we've also seen that the period is 2 pi. In other words, it repeats every 2 pi. So that's going to be helpful. Right, what I'm going to do is I'm going to graph the function between x equals 0 and x equals 2 pi. That's about 6 1/4. 1, 2, 3, 4, 5, 6. So it's going to be out to here. And then it repeats. So I'm just going to copy it over and over to the left and right as many times as I need to. The sine function is also symmetric with respect to the origin, which is going to be helpful here. And these last two, these are the two that I really like to focus on. The x-intercepts and the location of the maximum and minimum values. When I'm graphing things, we start doing phase shifts and amplitudes and all the rest of this, these are the key points that I'm focused on. If I can get these points in the right place, then sketching the graph means just start at the maximum, go down to an x-intercept, go down to the minimum, come up to the x-intercept, and so forth. All right, so I know that the sine of function is 0 at multiples of pi. Right, so I'm going to put my x-intercepts in here. I'm going to do 0. Pi is 3.14. 2 pi I had in here, that's about 6 1/4. And let's do this going the other way also. Let's do negative pi and negative 2 pi. 1, 2, 3, 4, 5, 6. Plus a little. There we go. Okay, there's my x-intercepts. I know that the maximum values occur at, let's see, where is the sine equal to 1? Well, the sine is going to be equal to 1 at pi over 2, right? So that is halfway between 0 and pi. And like I said, I'm going to make this point pi over 2 comma 1. So that's going to be my scale on the x-axis, on the y-axis. Then I know that the minimum value occurs at 3 pi over 2. Right, so that's in the middle of pi and 2 pi. So between those two, I'm going to go down to -1. This is 3 pi over 2 comma -1. Now that's a helpful point to keep in mind, because as we go through all of these things, that's a key fact that isn't going to change. The maximum and minimum values always are going to occur halfway between a pair of intercepts. Okay, and this really is enough to get the graph. Right, the graph starts at 0, goes up to the maximum, turns around, comes back down, continues down to the minimum, turns around, and comes back up and keeps going, right? It keeps going. Now look, I'm going to go about 1.5 units over. See, I'm looking here. So that's about 1.5 units. I'm going to go about 1.5 units again, and that's more or less where my next one. Remember, we're sketching, right? So it's not perfect. Now, all I have to do is duplicate this on the other side. It's going to go down to a minimum halfway between these two intercepts, come back up. It's going to come up to a maximum halfway between the two intercepts, come back down, and it's going to repeat this over and over again, right? And that's the graph of my sine function. You really need to put this one in your head, right? Because we're going to use this a lot through anytime we're trying to graph. All we're really going to be doing is some kind of variation on what you see right here. All right, so what if we throw this omega in here? Right? What effect does that have on the graph? Okay, well, remember, our sine function goes from 0 to 2 pi. That's one period, right? That's how long it takes for it to start repeating. Okay, so what happens if I replace x with omega x? Well, if I start my period at 0, right, when omega x equals 0, x is still equal to 0. So that's still the starting point of a period. Now, where is the ending point of this period? Well, this function's first period ends when omega x equals 2 pi. And that happens when x is 2 pi over omega. And that's a formula we're going to have, right? You need to hold this, write this in your notes or wherever, right? The period of the sine function is equal to 2 pi divided by omega. Okay, so let's see how we can use this. All right, so let's see how we can graph this thing. The first thing I'm going to do is determine what the period is. And remember that this 2 is omega, which means the period P is 2 pi divided by 2, which is pi. Okay, so the first thing I'm going to do then, I know that my sine function is going to start, my graph of the sine function is going to start at 0, and it's going to end here at pi, right? I'm going to get an entire period, an entire repetition of this graph in that one space. So I want you to think about what happened now. The original graph, it took 2 pi units to get this done. Now it's only going to take pi. So this has effectively scrunched up the graph, right, into a smaller space. Okay, so now look, what do I know? I know what are my x-intercepts. My x-intercepts are 0, because that's where the sine function starts, right? Sine of 0 is 0. There's going to be, skip a space here. I'm going to put another one there in a minute. There's another one where it ends, because it has to end at the same place it starts. That's pi. And the second, or the second intercept is always exactly in the middle between the other two. So the midpoint between 0 and pi is pi over 2. That's where my second intercept is, right? It's going to be right about here. Okay, now what else do I know, right? I know that the maximum value occurs between halfway between the first two intercepts. Well, halfway between those two is pi over 4. So pi over 4 is where my maximum is going to be. That's going to be pi over 4, comma 1. And I know that my minimum, let me switch colors here. The minimum is halfway between the second two. All right, well, that's a little tricky. Let's actually work this out. I want the midpoint of that interval. So it's pi over 2 plus pi divided by 2, which is, let's see, you do a common denominator here, right? Make this pi 2 pi over 2. So that's 3 pi over 2 divided by 2, which is 3 pi over 4. Halfway between these 2 points, go down to the minimum. 3 pi over 4, comma -1. Now I know you could have just, if all you're doing is sketching the graph, you could have just said, okay, halfway is about here, go down to the minimum, there you go, right? But you do need to get in the habit of being able to calculate, where is the midpoint, what is the actual x value here, because for no other reason you're likely to be asked that on tests. Okay, so this really does it, right? Now I know what my graph looks like. It's going to go from the minimum, or from the intercept up to the maximum, down to the intercept, down to the minimum, up to the maximum again. All right, now if you want to keep going, let's see, my second period is going to be from 0 to 2 pi, and the midpoint is about here, and it's going to just do the same thing again, over and over. And there's my graph, the exact same. You notice it's got the same pattern. We're going to see the same pattern, this up and down oscillating pattern. We're going to see this repeat over and over and over again. It's just squeezed into a smaller space. All right, so let me give you one, right? Take a look at this thing. See if you can't figure this one out real quick. All right, so I'm going to start in the same place. All right, let's find the period. The period is 2 pi divided by 1/2, which is 4 pi. Okay, so now my graph is stretched, right? It's going to take 4 pi. Let's see. This is going to be 0. I'm going to run out of room here, aren't I? So let's see. Let's say this is, that can't be 4 pi, it's even. I'm sorry. Let's say we count by 2's here on the x-axis. So this will be 0, 2, 4, 6, 8, 10, 12. All right, so 4 pi is 12.4, so it's almost 12.5. It's going to be right there. Now, where is let's label this x intercepts. I have 1 at 0, I have 1 at 4 pi, and I have 1 in the middle. Right, the midpoint between 0 and 4 pi is 2 pi, which is 6 something, so that's going to be right about here. Okay, so where are my maximum and minimum values? So the maximum will be between the first two x-intercepts. That's going to be at pi. So I'm going to go over 3 something and up. That point is pi, comma 1. And my minimum is going to be between the other two. Between 2 pi and 4 pi, the midpoint there is 3 pi. So I'm going to go 3 pi. That's 6.2, right? So that's going to be halfway between these two. Right? So it's going to be down here. And we'll call this 3 pi, comma -1. And there's my graph. Up and down, up and down. All right, it's going to come up again over here somewhere, and it's going to drop and do this same oscillation. Okay, so that's how that's our first parameter, right? That's how we take into account the periodicity of a specific sine function. So where are we going next? Well, next we're going to kind of do the obvious thing. We're going to see what the cosine function looks like.